Hello everybody, getting ready to do 3.3 part 1 pre-calculus math today, classwork. If you need a note-taking guide or if you need a solution PowerPoint for a previous homework or this homework actually for 3.3, email me here for that. And 3.3 properties of logarithms. We have 58 points here of classwork note-taking in your lecture, and you have 2 points here to go in your notebook, so have your notebook out for that. And then teachers, today's bell work is find the value of base b so that the graph of f of x equals log base bx contains the given point. So we got 2 points here. So give your students 5-6 minutes for that. And then here is your response boxes for your solutions. Okay, everybody, welcome back from your bell work exercise here. Let's go through our solutions to finding the value of base b so that the graph of f of x equals log base bx, which contain these points here. So for this one here, 5, which is our y here, which is f of x, is 5 equals log base b, 32, which is x. So we need to solve for b here. So to do that, we know that b will be to the 5th power will equal 32. So what would our base b to the 5th power would equal 32? It would be 2 to the 5th, correct? 2 to the 5th power equals 32, so that would be your b in 117. Then for 118 here, 4 is our f of x, and then log base b 81. So b to the 4th power will equal 81. So what to the 4th power will equal 81? Well, it will equal 3. 3 to the 4th power will equal 81. So there's work. Let's get into our lesson today. Page 1 goes in your notebook. Students, get your notebooks out. Change a base. Most calculators have only 2 types of log keys. One for common logs, base 10, and then one for natural logs, base E. Although common logs and natural logs are most frequently used, you may occasionally need to evaluate logs to other bases. To do this, you can use the following change of base formula. This will help you. This will bail you out so many times you won't believe it. Okay, this is on your classwork sheet. Let a, b, and x be positive real numbers such that a cannot equal 1 and b cannot equal 1. Then log base ax can be converted to a different base using any of the following formulas. So base b here, log base ax, would equal log base bx over log base b a. And then base 10 here, if log base 10 here is x, we can find by using log base 10x over log base 10a to find our base here for this one here. And then base e would be log base ax would equal natural log x over natural log a. So basically it's like taking the log of your furthest term here over the log of your close term here. It's kind of one way of thinking about that. So let's get into an example for this. Changing bases using common logs. Log base 4, 25, how would we find that? So by using a change of base, we go log base 10 of 25 over log base 10 of 4. So this is using this rule here, log base 10x over log base 10a. So when we do that by using a calculator, and you'll get these numbers on your calculator, you have you'll get a quotient here of 2.32 by using the change of base formula. So by figuring this out by using change of base, you can use on your calculator use the change of base formula here. Okay, let's move on to another one here. Log base 2 12. How will we do that one? Well, log base 10 12. So your furthest one over your close one here using your common log here. So when you punch that in your calculator, you'll get this quotient here, which is 3.58. Okay, so let's go into our first guided practice here, page 5 on your lecture here. Changing the base. Rewrite the logarithm as a ratio of common logs. So we have a situation here where we're going to have to use change of base. So this is your guided practice here. Students, this is on you. So pay attention up here so you can do your independent practice. So let's do number 9 here. So log base A 3 over 10. So we're going to take log base 10 3 over 10 over log base 10 of A will be our situation here. So that would be the way that your procedure here of solving this is take the log of your furthest away and then divide it by the log of that's close here of your base. And then once you do that, you will have your solution there for that. Okay, let's move into example 2, changing bases using natural logs. So now we're going to change this using natural logs. We got log base 425. So the way we're going to do this, we're going to take natural log 25 over natural log of 4. So we're using this rule here. We're going to take the log of x, or rather the natural log of x, divided by the natural log of a. And then when we punch this into our calculator, we get this quotient here, which results in 2.32. So using change of base, we come up with 2.32 for this situation here. Okay, so now we have log base 2 12. So we're going to use change of base. So we're going to take the natural log of 12 over natural log of 2. So we have a quotient here, which is this situation here, 2.48491 over 0.69315, and that's 3.58. So using change of base, we can we can solve that. So into our next guide practice here, evaluate the log using change of base formula, round your result to 3 decimal places. Here's our response box, and students, this is yours for your independent practice. So how are we going to do this, class? Well, we're going to take the natural log of 1460 divided by the natural log of 15, and then we get this number here for that quotient. Okay, then, I'm not going to give it away. You do what you got to do. Okay, into our next property here of logarithms. This goes in your notebook, so get your notebook out. You know from the previous section that the logarithmic function with base A is the inverse function of the exponential function with base A. So, it makes sense that the properties of exponents should have corresponding properties involving logarithms. For instance, the exponential property a to the 0 equals 1 has the corresponding logarithmic property of log base A 1 equals 0. So you see the similarity here. This is a base for an exponent, and then this is a base for a logarithm. And then, so a to the 0 equals 1, so a to the 0 equals 1. You just have to go across your equal sign. You have to do. Okay, let's go into a table here. Properties of logarithms. Let a be a positive real number such that a cannot equal 1, and let n be a real number. If u and v are positive real numbers, then the following properties are true. A logarithm with base a, and then a natural log. So, product property here, log base a uv equals log base a u, plus log base AV. So we're adding here for as our product here within the logarithmic situation. And then natural log UV will be natural log U plus natural log V. And then the quotient property here, log base AU divided by V would equal log base AU minus, now we're subtracting log base AV. So we're subtracting our denominator from our numerator, this situation there. And we do the same thing here for natural logs. We subtract from natural log U the natural log V. And then our power property, log base AU to the n would equal, and then using our exponent property here, n times the log base AU. That's our power property here of logs. We move this over here like that. And then we do the same thing with natural logs. We move this over here, so it'll be n natural log U for our using our power property of logarithm. Okay. Let's get into an example now and try these out. Using properties of logs, write each logarithm in terms of natural log 2 and natural log 3. So natural log 6, how would we write that in terms of natural log 2, natural log 3, like this? So we can use the product property there. Rewrite 6 as 2 times 3. So natural log 2 plus natural log 3 would be the same thing as natural log 6 by using our product property of logarithms. So B, natural log 2 over 27. So natural log 2 over 27, now we subtract natural log 2 minus natural log 27. That's our quotient property of logarithm. And then natural log 2 minus natural log 3 to the third. Rewrite 27 as 3 to the third. This will be 3 to the third here. So natural log 2 minus 3, so now we're going to use our power property here of logs. We move this 3 in front of our natural log, 3 times natural log 3. So that's our power property there of logarithms. So let's get into a guide practice now. Okay, rewrite the expression in terms of natural log 4 and 5. So those are factors of 20. And then down here, students, that's on you. But we're going to do 21, so pay attention. Natural log 4 times 5, that's it. Would be natural log 4 plus natural log 5. So you could simplify that, natural log 20, into this here. Okay, our next example 4, using properties of logs. Use the property of logarithms to verify that the negative of log base 10 1 over 100 equals log base 10 100. So negative natural log 10 of 1 over 100 would equal the negative of natural log 10 to 100 to the negative 1 power, right? 1 over 100 is 10 to the negative 1. So we're just going to rewrite this as this. And then once we do that, we're going to move this now out in front of here. So the negative of negative 1, we're going to use the power property now of logs, base 10 100, power property, and then when you multiply negative 1 times the negative, you get basically it's 1 times natural log 10 of 100. So we simplified that by using the power property there. Okay, let's go into a guide practice. Use properties of logs. So we have log base 5 1 over 250 equals negative 3 times negative of log base 5 2. So what in the world? Okay, everybody, we're going to get into our guided practice here, number 7, and we're going to use properties of logs to verify this equation here. Students, this is yours down here. Pay attention up here so you can have an idea what to do down here. So what we are doing here, log base 5 1 minus log base 5 250. This is a quotient, which is this right here, log base 5 1 over 250. That's just another, this is another way of stating that. And then here, negative 3 minus log base 5, 2, well, equals 0 minus log base 5, 125 times 2. So again, this negative out in front is a negative 1. Log base 5 of 2 times 125 is 250. So it's going to reciprocate 250 to 1 over 250. So we're still saying this by this statement here. And another way of stating it, so the negative log base 5, 5 to the third times 2. So again, this negative is going to modify this. This is again 250. 5 to the third power is 250, or rather 125 times 2 will be 250. And then this reciprocates that, equals the negative of log base 5, 5 to the third, plus log base 5 squared, or 2, well, not squared, but 2 here, log base 5, 2. And then, so what this is, it's a reciprocation of this product here, which is 5 to the third is 125 times 2. So we're using the product property here, which is reciprocated, which is again this situation here, is what this is saying here. So we're saying the same thing here, but it's in a different, kind of a different form. And then again down here, the negative of 3 log base 5, 5, which is, so it'd be 5 to the third, it'd be 125, plus log base 5, 2. So again, we have a product property here. This is 125 times 2 would be 250, and then reciprocate it. So it's log base 5, 250 here, equals negative 3 minus log base 5, 2. What the heck is that? Well, that's 5 to the third power here, reciprocated, which is 125, times 2, which is 250, and then reciprocated here by this negative 1. So it'll be log base 5 of 1 over 250. So there's like 6 different ways of saying, or actually 7 different ways of explaining this relation here, which is what all these statements are. You got 7 different ways of saying that, okay? So there you have it. And that is your lesson for today. Pre-calculus math, solution PowerPoints for homework, tasks, quizzes, note-taking guides, solution PowerPoints. Email me here. Thank you very much.